What made you guys want to build a graph database?
To reason better, models need to reasoning pathways, like how to reason through. And the ontology, which is the foundation of the graph, which is the model of the world for the graph data, helps agent to reason through something way better. And in our practice, we have like a lot of really fruitful and really interesting and useful scenarios where it happened. The biggest unlock for me was the reasoning, right? I don't know how well you remember, but like early 2025, GPT-03 came up and everybody was talking about the reasoning and how reasoning will change everything. But like it wasn't clear back then before the GPT-03. And when 03 came up, it's just like, oh my God, this thing can reason, this thing can think. And I was sitting on a call with a client and he was trying to figure out like very complex problem. And I was completely clueless. I was just like, I didn't understand what he meant. And I just like, hey, let's stop it here. Just chat, just tell me what you're talking about. And I created the transcript and I fed it to the 03 and it just break it down perfectly flawlessly into the coherent narrative. And I was just like, oh my goodness, that's a completely different game. And that was like correspond with the moment where the IQ of the model became roughly as my IQ. My IQ is roughly 130. So the IQ of the model was also like the 130. So that was the big moment. So that's the short answer to the question. Why the
130 IQ? Wow, that's a flex.
Of course, but, yeah. Why do we need to record the podcast and not flexing?
Can you explain what ontology means? I've heard that word a couple of times from you folks, but it's the first time I've heard it actually.
Okay, yeah. So ontology is the model of the world. It comes from the philosophy, right? So essentially, ontology is what exists, what's out there. So it's kind of all the tables and chairs and glasses. This is the ontology of the world. This is something that we agree on, something that exists. And in the data world, ontology is something that model the world of the, let's say, of the business process, right? So let's say if we work in the retail, we would model the consumer, the shopping cart, the item, right? And we will see how they are connected, and consumer would have a shopping cart and the item will be inside the shopping cart. And this way we will build the ontology as the sub model of the world where this consumer operates. And then we of course build the data model and then we build the business logic. So ontology is the kind of foundational level of modeling that goes even before the data layer is there.
Yeah, and I think just to add to that also, you asked essentially why are you guys building a graph database, and I think often there's a lot of baggage that come with these category names, right? Like graphs and associations that people have. But I think in general, one needs to think about essentially what is the most essentially abstract or generalizable way to represent data. And essentially the graph is kind of the most generalized version of this, because any other sort of data representation can be represented as a graph, right? Even if you think actually about a text, right? It's just a sequence of tokens that link sort of linearly to each other. So in some sense, if you want to think about, okay, what actually representation really generalizes, actually it is essentially the graph. But of course it comes with a lot of kind of baggage around like, categories like graph databases that are often optimized for this like large scale traversal of nodes and edges. But I think the way we kind of approaching is more sort of from first principles, instead of thinking about, these database categories, but think like, okay, agents are kind of a new type of operator that gets introduced, a new type of database operator. And its fundamental concern is that it needs to assemble context, I guess, perform a specific task, and then it also needs to write back its results to a certain like store, I guess, to drive essentially the next actions, right? And what it fundamentally needs is essentially a kind of understanding of the domain, right, it operates in, both to know that if you're asking questions about customers, need to understand, okay, what I mean by customer and represent that data model. And also fundamentally, as Andrew described with sort of ontologies, we live in a world of objects that relate to each other, right? Essentially, so in that sense, it's like a graph. And this is kind of the way we can represent a domain. And then how you kind of implement this then in a sense of a database, like at the storage level or the indexing level and things like that. These are kind of also implementation details in some sense that you can optimize for, right? But fundamentally, we're thinking working backwards from an agent who needs to understand the world it operates in and kind of contributes. They need essentially a general sort of representation of the data. And so there's also a lot of kind of history there as well around the problem with relational databases and this sort of mismatch between an object-oriented world and sort of the relational world and things like that. And that's why it's been all these ORMs like, Prisma and Drizzle come up, because they were kind of like bridging between the two. But now kind of we in 2026, I guess we will have the opportunity to rethink, okay, what would actually an optimal state layer look like for agents, essentially.
I think it's a good question, the relational database part, because as you said, like our objects in the world have some sort of relation, can be directional, bidirectional, etc.
Mm-hmm.
I think that's why we built relational databases. So I guess my next question would be, given that I think my assumption is that an agent can do anything that programming code can do, right? In programming code, in that world where we write the code ourselves, we use relational databases and we use SQL queries, and maybe we use ORMs. I guess you can talk more about that. But from that point of view, why can't the data be expressed, let's say, with a relational database compared to a graph? So what are the pros, the cons? And did you even consider, let's say, using Postgres?
Yeah. So essentially, I think the question, I would actually challenge the premise of the question, because it's not like why we cannot model something with the tables. It's more like try to talk to the child, right? Try to talk to the child, and then like how the child would reason, like very, clear consciousness. Like child would never reason through like the table, almost like as an accountant, right? Like sometimes very autistic children reason like this. But most children reason like this. Oh, I have this toy and I lended this toy to Ben and Ben kind of broke it. And that, so they reason through the graph so they essentially build the whole model of the graph. And the graph is the most natural way for people to reason. And because LLMs supposed to reason like human because they learn on the human corpus. So this is why it helps to reason better. And essentially thinking about the data of the relational data, it's not like we build the relational databases because it was a great way to do stuff. It was because we were resource constrained. The same way we use Excel, right? Like imagine like we would never have Excel. We always write a Python code. How much better it would be? It would be way better, right? Because you don't have to constantly cram this weird little tables and cells and this kind of clunky formulas. You would write a Python code, which would be type safe, which would be all tested and so on. But it was unthinkable because this way you need to learn how to code, right? So the same way with the I always butcher this name, relational databases. It's like SQL emerged not because we were like, as Ragnar mentioned, thought from the first principles what would be the good way to a certain domain to work. And some domains, like, again, they need the tabular data, they need the rectangular data. But rather like, how do we make something that in a constrained reality where we have like very little resources and very few people who can code would be the good way for us to store the data, right? Because databases were like, it's a base, it's a storage, right? It's a storage layer, like essentially it's how it emerged. So, and graphs were like, they were forever, and the graph theory was forever. But among the people who were in the data industry, the percentage of people who can operate graphs were tiny. So that's the huge constraint. And also it works in other direction as well. Like you don't always need data. You don't always need graph, right? Like what we are thinking about, because we're using Lens, how about we view, like the good model is you look at something and think about it like, what is the affordance to this storage? It's not like I use this table, but it's like, what is the mental model that I use to interact with this data? And you can think of it, okay, in my case with the consumer and the items, right? Consumer would have the basket and items are in the basket. So that's kind of the graph. But then I would create like a 3 tables. One of them would be consumers, one of them would be items, one of them would be baskets, right? And I view them as table as well, right? So that's the flexibility that you can almost like shape your data and you can forge your data and you can look at your data the way you want. And it's, again, because it's too resourceful, we kind of almost by the sheer amount of constraint, we went into this valley of, oh, SQL is the solution, right? Because everyone knows SQL, or like at least a lot of people knows SQL. So this is the good solution. But it's not, because it's very limited, and you cannot model more and more complex things with it. But the graph can be essentially represented as SQL, right? Because you can, if the graph is simple enough, if the ontology is simple enough, you can represent the graph as SQL. You can represent the graph, for example, as the set of tables. You can represent the graph as the, let's say, as a set of, what would be another good example? As the set of lists, or as a set of documents, right? So like, and vice versa. So like, I think the big unlock that we have now, we don't have to think in this kind of very narrow and very limited categories. We can think of like, what is the good mental model that we need to have around our data, and how we can implement it, and how we can almost like collapse it into something more simple when we need something simple.
I mean, also like taking a bit of a step back as well, I think a lot of the database categories emerged also in the past, in history, like constrained to like the availability of technology or adjacent technology at the time, but also like designed for kind of primary operators, right? Like the relational database like Postgres and MySQL for sort of these old OLTP workloads where you have an application that retrieves records and writes records, and then essentially we had this emergence of warehouses, right, and data lakes, and then convergence to the lake house, right, for like kind of this analytical workloads. And also there you have a well-defined operator, for example, the data scientist who needs to do kind of large aggregate queries and develop like columnar storage and things like that. These kind of categories like emerge for a specific type of operator, and now essentially we have a completely new operator that has fundamentally different workloads. And usually these databases were optimized in some sense, also in terms of the economics or also the scale for that sort of workload, right? Rather it's like on how things are queried, how things are written, what guarantees you need to provide and things like that. But then, as I mentioned also initially also around what technology was available to build at the same, at that point in time. And so now in 2026, and obviously the last few years, for example, there's been like a huge sort of increase in maturity of object storage, for example, right? And a lot of the primitives that allow it to essentially build actually durable storage, durable database over S3. And so, of course, if we had that, 20 years ago, the landscape would look very different. So a lot of these categories have emerged because of this sort of historical context and things like that. And we know that, fundamentally, when there's a completely new sort of technology, in this case operator, that this gives rise to a new infrastructure, right? And we're not saying that Postgres is going to die tomorrow, but essentially agents who essentially are now being deployed, at huge scale across organizations that have a very different like read patterns, right? It's more exploratory. They look at the record and they look at adjacent things, and then also the way they write, what does it tell us about concurrency and things like that. And so rather than calling it graph database or X or Y, Z, like essentially we're thinking more, okay, working backwards from the new agent operator, what would be the optimal database or state layer for them, and also leveraging every technology that has emerged in the last few years, right? Like object storage, but also these open table formats, right? Like Iceberg and Lens and things like that, and kind of designing around that. And so and that kind of affects everything from when you build a database from, okay, how do you present the data at the storage level, right? What indexing or query execution do you use? And then fundamentally also what query language do you expose, right? And so the graph part for us is kind of just one element of essentially the interface that we expose to the agents to assemble context. Because essentially retrieving context will mean you have to do some combination of vector or semantic search, full text search, of traversing relationships, but also doing structured filtering. And so we're combining all these in kind of one runtime. And in the past, I guess, like over the last few years, these kind of workloads have been fragmented, where you have vector databases, then you have these analytical databases, and sort of obviously search sort of like solutions like Elasticsearch and things like that. And so this is fundamentally, I think, what this is about, rather than, let's say, a graph database, but more like, okay, a new type of state layer for the agent as the primary operator. And that means you can provide superior like sort of properties to the agent, like in the case of context assemblies, like can you optimize for precision and recall, of sort of the retrieval, but then also around the economics, can you actually store terabytes of data in a sort of efficient and cost efficient manner and index it and things like that. So really optimizing both the economics, but also the actual properties of the databases for agents as kind of operators. And then again, one last thing, and there again, like thinking, okay, what does the agent actually do, right? In the past, we've been like kind of mostly using agents or chat or LLMs as kind of chatbots, right? Asking a question and we retrieve an answer. And this worked also somewhat well, also plugging it onto existing systems. Maybe you have some kind of like a vector search on top of it and things like that. But I think the thing that we are most interested in is actually when agents become operators and actually start writing a knowledge back or data back and actually become actors in the organization rather than just essentially chatbots. And that means, okay, they're solving the right side of the equation, but then also then falls into coordination, right? Essentially, when you have agents reading and writing and then essentially other agents picking up what was written by another agent, how do you actually make sure that this like global behavior actually stays coherent? How do you think about governance, that, when agents write that humans can still be in the loop? So we're kind of like almost thinking at one level of abstraction above the raw database level, right? So if you think about just providing a pure database versus for agents, we need kind of one level above. And that's also where the ontology comes in, right? Can you provide a data model that mirrors the world, the domain for the consumer, for the agents, but also solving governance and coordination of agents around that sort of state layer. And this is kind of maybe more fundamentally what it's about, and saying like, we are a cooler Neo4j built in 2026, basically.
Good point. I think you raised a very good point about the bad dependence of databases and general technologies. I think Postgres is 40 years old, maybe even more than 40 years old. I think you nailed the hammer on the nail. Sorry, the nail, whatever it's called. I think you're completely right when you say that it was built for basically the past, and definitely it's not going away. I think you can still use it for a lot of things, and of course all the agents are trained on it, so they know very well how to use it, so it's going to be hard to remove all that network effect. But it's a great point that when we have a new type of operator that has different read-write demands and percent and distributions and etc., it requires something else. So then I guess the natural question to ask is, what are you guys building exactly to solve this problem?
Yeah, sure. I mean, as I kind of described this earlier, so we're building this new state layer or knowledge layer, essentially designed for agents as first-class operators. And some people would call it, let's say, a company brain, or essentially you can understand it as essentially unifying knowledge across the organization under sort of a world model, and then essentially providing this as a substrate for agents to retrieve context, perform work, and also like coordinate with each other. So in some sense, we're seeing this as like the opinionated foundation to run every agent workload on top of, rather than essentially currently how we're seeing, or currently the essentially initial wave of AI was essentially deploying a bunch of point solutions duct taped across different systems. But we see actually the actual companies that are going to be really running on the AI, they need to build essentially on the foundation designed for them. And sort of we build this kind of opinionated infrastructure that solves essentially the problem around context, coordination and governance in sort of like one foundation. But the big philosophy behind it is obviously to be like fully composable, so not providing another siloed SaaS, monolithic SaaS solution, but actually providing essentially almost like a set of Lego blocks that are composable with the rest of the stack. Because I think the reality is that now companies have such a much higher engineering budget than in the past, who can build things internally. So just essentially providing a black box solution doesn't work anymore, but providing essentially the building blocks that allows them to essentially deploy their engineering budgets in an area where they can drive leverage for the organization, and usually that will mean actually building the specific agent workflows, and then the specific ingestion pipeline, things like that, but not sort of debugging, database indexing, concurrency issues at the lower level, basically. And so that's where we kind of fundamentally see ourselves like fit in. And for that reason, we also built on sort of open source all the way down from essentially the open table formats. We are kind of betting on length, but we're able to support other open data formats, but also like on open source query engines like DataFusion, and also like Arrow, so really sort of, and then obviously object storage native, so that companies can actually own sort of the data and storage, and so that's maybe Andrew, you have something to add.
So I would approach this question from the slightly different angle. Is I really like when I was like super young, I was deeply involved into like listening to a lot of like Steve Jobs presentations and kind of his reasoning, because I think it like the way he could frame things for me was always kind of crazy deep, and sort of he could package things into the very simple set of worlds, and it will be like very deep and very interesting. So like at one point he said like the things are packages of things. So like the product is a package of things. Some things are like implemented well, some things are not implemented well. So I think every like if we call it like a database, every database is a package of things, right? Some of the things are like highlighted, some of the things are sort of muted. So and if you have like a good combination, it's almost like a mixture, right? You essentially push some ratchets to the high level, some ratchets are going to be rather, underdeveloped or maybe like even absent. But you will have like a product, and of course you have a market, and you need to see like how well this product will perform. So the idea of like Omnigraph, the tool that we build in, is just like there are things that are sort of heavily emphasized there, like for example the type safety, right? That nothing can go to the database that is not type safe, doesn't have a specific type, because otherwise it will break it. Why? Because agents are very creative. They tend to break things, right? And they tend to create like a weird data that is never that breaks the schema, and this way it breaks their own traversal of this data, right? Their own interaction with this data. So another thing would be the as code, right? The paradigm as code. Why so? Because like if you ever tweak any database, you need to like change those never-ending like checkboxes. And I remember like working with Oracle early days, and it was just like a nightmare of just like this. Oh, you need to check this, and this doesn't work, and this, So like essentially the idea is just like everything as a code, right? The schema as a code, the configuration as a code, the context as a code, because you can actually create a query and sort of store it as almost like the agentic tool in MCP, right? So this is something that we heavily emphasize, like really, really heavily, right? Because we don't want for people to start configuring it manually, because it's a nightmare, right? We want for the agent to configure it for itself, and then also like to have this set of guidelines in the form of all of this: schema as code, queries as code, policies as code, settings as code,
UI as code.
Yeah, UI as code. So like everything is code, and for agent to be able to create those for itself and then follow this guardrails, right? So I think the most efficient way to now interact with agents, it's like agent create the framework for itself, but then this framework should be enforced, right? So like you would say, now you need to create a framework. So we are working on a framework. It can be the schema, it can be like the set of markdown files, it can be even like the development environment, right? Now you have this framework, but now you need to follow this framework, because otherwise you will break everything. So this is pretty much what we're trying to emphasize, right? This part of like, yeah.
And this schema or this framework is basically programmatically enforced here. So the agent has some wall to hit when it gets creative, so it can iterate on a loop and fix itself eventually. Is that so?
A lot of walls, a lot of walls, not just one. It's going to be like,
just to add to that, I think this is where in the past for humans it was annoying to have too many guardrails, right? And that's why a lot of the essentially tools like open-ended note-taking or like free-form things, canvas and things like that, like had like most distribution, because it's like very easy then for humans to kind of use it. But agents kind of don't care of hitting walls, because they just in the next loop run or sort of loop iteration, right? They just recover from the error, right? So in some sense, like this is kind of what you should kind of optimize for. And and also Andrew mentioned also the sort of the aspect of agents being creative, but I think, and that's why, and therefore needing guardrails. But what I think is even more interesting with the ontology or the type safety is that it also provides almost like a prior on the LLM or the agent on how to store that type of knowledge or even retrieve that type of information in the first place, right? Because if your target schema ontology has required fields, right, then it forces the agent to essentially go and fetch that information, versus like essentially an unstructured markdown that doesn't constrain at all essentially how you should store that information. And so, and like we also have developed over the years like a huge amount of frameworks on how to actually model a process, anything from the para method, right, for tracking like your personal productivity, to like also thinking tools like a morphological matrix or XYZ. So we have a bunch of frameworks, or even in sales, right, you have like, MedPick, right, and all these sort of sales frameworks says, okay, these are the things that you should consider. And you can also like represent these frameworks, I guess, in the ontology. And that means that now actually all your agents that actually read and write conform to that sort of a framework of either like acting or reasoning. And of course it can evolve, right? Agents can propose changes to ontology or find better frameworks. But I think this is kind of what makes it super interesting, that you can really then enforce almost like a process. For example, we're also exploring it around like our, using it for GTM, kind of automate, like replacing CRMs and everything with that. And sort of you can essentially embed a lot of priors on how to optimally do, for example, prospecting and all these things in the sales process in the ontology itself. And so when you have required fields, it forces then, for example, to retrieve information about your leads and things like that. So this is kind of like how I would see it, not just from the negative side of like ensuring governance, but just like essentially of making them better reasoners.
Got it. So it's almost as
Can I? Oh, sorry. Go ahead. Yeah.
I was gonna say it's almost as if it's a token efficient way of encoding a process instead of writing sentences of, hey, do this, do that. When you have a required LinkedIn URL field, the agent knows that it has to fetch the LinkedIn field.
Well, not
and even if you have
necessarily.
a skill, you might not be able to enforce it, right? Because it might ignore the skill, right? Or the context is like polluted,
Right.
and now it forgot that 200,000 tokens ago it mentioned you should enrich that information you mark down in that way. But if you get an error at actual write time that it's missing a piece of information, then essentially it's much easier to enforce that. I think especially in a multi-agent process, because if the write of an agent becomes the read of another one, then you can see how essentially structuring the knowledge becomes like compounding in terms of like reliability, because essentially every sort of downstream agent, but also you might even have deterministic systems that based on information in there will trigger some workflow, like for example sending emails to customers with first name, last name. So it needs to have a reliable sort of structuring of that information.
Yeah, let's linger on one thing, because I think it's so few people like understood it yet. So I think just for us to unpack it like in full, I think would be super useful. So if we go a little bit to the history of the databases, like what was the most kind of brutal and most destructive process for human psyche in the database? It was schema migration. Like every person who worked with database like hated it, because it's literally like the worst process in the world. And we try to avoid it at all costs, right? Because I remember like spending like nights and nights with the broken schemas and figuring out like how the data got broken and the integrity is broken and now nothing works, right? So like that was brutal process. And of course, like the more we evolve with databases, like there's like a lot of good solutions, like for example, the Atlas, right? And so on emerged, like to migrate the schema in a nice way. But MongoDB emerged as the sort of response to this problem. Hey guys, how about you don't have to enforce schema anymore? Everything will be schemaless, and you can just sort of create the documents, and if the document fits, that's great. You will have the structure, but if not, you don't have to like spend nights and nights in your office just working with the schema. And it was a great idea. Like overall, it was an amazing idea. Why it was the amazing idea? Because it was oriented towards human and what humans are bad at, to maintain the structure, right? If you have your kitchen, like wait, like you have a perfect kitchen. Wait a couple of days and everything goes to mess. Cook one dish, everything goes to mess, right? And you need to clean up, you need to reorganize, right? So like we naturally tend towards like a maximum entropy, to increase in entropy when we do something. So because of that, it's really hard for us to maintain the structure. So this is like where we were like for a long time. But now this paradigm changed, right? Because agents love to maintain structure. They can do it like whatever time they want, like as many times, as many iterations, they're doing it really fast, right? But the problem is the opposite, because the moment they don't have structure, they start to break in things and creating like non-existent fields, trying to create non-existent fields, and everything breaks. But not because they are like messy, but because they are like trying to like be as useful as possible. They try to cramp as much data where they sort of trying to like almost like overfit for the task, right? So, but they also love to enforce the structure. They always love to create these frameworks. They always love to migrate these schemas. Something that they do like on the especially the latest generation of models, it's doing like on a very high level. So now, because of that, the paradigm is changing, right? It's not like the problem now we need to enforce the schema. On the contrary, now we can enforce it in a beautiful way. The problem now, like we cannot afford schemaless anymore, because with the schemaless comes a lot of entropy on a much higher scale than a human, right? So just to sum up my sort of long story, like humans are messy and we hate to enforce order, like generally. Some of us like, but like most of us hate. And this is, we naturally goes to the maximizing entropy. Agents are even more messy than humans and even more creative and even more overfitting, especially this generation and previous generations, of course. But the agents, at the same time, they love to enforce things. They love to create the frameworks. They love to create the guardrails for themselves if you just ask them nicely. And this is like one of those things that we figured out and we implemented fully in the Omnigraph and our other products.
And I also just want to add kind of two things as well. I think it's also interesting to think about like, again, organizations like from first principles, because I think in the end, like what kind of makes up an organization or company is that they also have some essentially model of the world, right? Essentially what it knows about itself and what it's good at, but also about what exists out in the world and the market itself. And then kind of uses that world model essentially to perform actions in the real world, from like producing goods, selling them, essentially in a way that essentially the market responds to it. And it only survives if it's able to essentially, produce something or value essentially that fits in the external world essentially. And the way it does that essentially is through processing of information, right? It kind of gathers information from the market, the responses, and kind of like then uses that information in a productive way internally, right, to organize itself to produce like a specific good or value, and then sort of like standardize it. And so how would you kind of define essentially a good versus a bad organization from that principle, right? And then one of them is obviously the entropy, because obviously the concept of entropy is kind of disorder. So essentially the more disorder exists in the organization in terms of information, the less would be actually able to really deliver onto the market essentially, right? Again, you could have also like a trivial state where an organization has very low entropy, right? It has like just maybe its world model is basically, a binary state, but obviously that doesn't correlate at all with sort of the external world. So in some sense, if we need to think about like what agents need to be able to do is actually maintain essentially a lower entropy state, low entropy state of that kind of world model, and then also in a way that kind of correlates with succeeding, I guess, in the market. And so fundamentally, then this structure allows them to really kind of reduce the entropy. And for humans, that was kind of easier to work around because they are slow and can correct and remove noise over time, right? Because you might have like essentially a disorder, or you might have wrong information somewhere, but eventually somebody will find it, correct it, or might not act on it. But essentially agents now are very different type of operators, right? They can react to things within seconds, right? And they can produce a huge amount of information. And so the default state you can imagine if a bunch of agents collaborate on shared state is that eventually this just drifts into noise. And I think this will be sort of the default state. And so everything kind of we built around that was also in a way to essentially build a state layer that can maintain essentially high signal over time. And this is where we will later also talk about the Git style sort of branching, but also why we need to kind of enforce structure, because you might add noise, but that noise is bounded, right? Because it might exist in one node in the graph, or it might exist in one, but it doesn't like, is basically the noise is not global. That if let's say the only thing you had is one markdown file, right? Then essentially it would be very difficult to understand, okay, what in here is potentially noise or sort of signal, and kind of validate it.
No, that you both made some very good points. But I think to this phenomena that the way I explain it to myself is that AI agents are compressing timelines of our businesses. Every timeline basically gets compressed. And the usual human timeline of a business is, look no further than data lakes. I mean, there's a reason they're called data swamps. They just get all sorts of data. They don't follow schemas. And eventually it becomes such a big mess that so many organizations are paying millions of dollars just to be able to get some valuable nugget of information of this whole mess that they really can't even make sense of as a single human. So humans have also proven that they also drift toward entropy, toward how you were saying. And to the point of NoSQL, I think it's a great point. I was going to say the same thing, that I think the NoSQL fad mostly came from, again, the first principles thinking that, well, humans work better when they don't have to do stuff up front. I just have data, save it. I don't want to think about it. Now, we know that the process of sitting down and thinking about what your data model is, thinking a little bit about the future, backwards, forwards compatibility, etc., is going to result in a better system long term. But we as humans, we naturally just want to procrastinate a little bit. We don't want to deal with it right now. I've always hated NoSQL and schemaless for production projects, namely because it's just such a mess after a while. After you get a sufficiently large amount of data, it only takes like one change to break a downstream consumer or downstream app. And then the debugging process is just so difficult because you look at the schema and you're like, okay, what was the correct? How should this actually look like? Which one is wrong here? Should I remove it? How do I, maybe there is some app, maybe out of my 10 apps, out of my 100 apps, maybe one of them handles the new field, but other 5 break. So do I fix the 5 breaky ones by adapting to it, or do I remove the field and fix the one working one? So again, I kind of see it in this view of agents are compressing the timeline, and any sort of problems you would have had with data before, instead of having them in 5 years, you're probably going to have them in 5 days now, especially when you have multiple agents running, compressing the timeline even further. And to the point of agents following processes very well, again, this wall, agents love hitting walls. I love putting up walls to my agents. I love, a simple example is putting up a linter or a code complexity tracker in your code base. It changes the code quality by AI massively, only because the AI hits the wall, fixes it, hits the wall again, and eventually gets to the right solution. Same thing with tests. Try writing AI code base without any tests, and put unit tests or put integration tests and see what happens. Yeah. So guardrails are great. I've also, I don't want to dive into this too much, but I've also thought a lot about this idea of, now that we love guardrails, now that our tools love guardrails and they help us a lot, how many more guardrails can we put? Because I think, again, to your guys' point, that some of the guardrails we previously put or previously decided not to put was mostly because the limiting factor was the human bandwidth and the human sort of willpower, I guess. How much toil can a human take before they stop following the process because it's just so annoying and they skip it anyway? So you might as well not make the process. Similar to recruiting or sales or any sort of business process in a company, there is a process. If you make it too cumbersome, humans just stop following it. I saw it in engineering, in on-call scenarios. Let's say you have a very big process of a run book of, you have to check this. Humans inevitably just skip some of that, miss it, etc. Because when it gets too much, I guess the humans context window gets too full and it goes out. But you made some very good points on this implicit schemas and errors acting like implicit processes or implicit sort of guidelines on what you have to do. I'm not
Can I add
sure
one more thing about the NoSQL, because I think it's interesting, because I actually disagree with you on NoSQL that it gets messy, because it's actually sort of move the schema one level above on the application level, right? So most of the schema is actually enforced. If you use the JavaScript, it's going to be types, or if you use the TypeScript, it's going to be a type interface, right? And it actually was great for the traditional apps, because the app is essentially kind of the view on the data. So if the types are enforced properly, nothing breaks, because it essentially gets caught on the level of types. But on the other hand, if you have some data that is sort of misaligned with the schema, you just get them and you will not lose them, and you don't need to migrate the schema. So that thing I actually liked about the Mongo and similar, the document databases. But I think now what is happening, because the apps are the apps, they're deterministic and they're boring in a sense, right? You never think about the app as a human, right? Because you think about the app as a consumer, right? And consumer needs to get something or, start writing to something and so on. but we think about the agents more and more as humans. And if you use the same sort of methodology, you would hit the ceiling very quickly, because if you say, okay, how about we create the technology where every agent will enforce their own type safety, right? So everything that I read would create the types for me, like sort of the interface. And then at some point, the agent will create the world model where they will be able to interact with the world in the type safe way, right? And if something breaks it, okay, that means it's not working. So it's kind of one way of thinking. It's not a good technology, but we can build something like this, right? So why is it not good? And the problem is they have different world models and they cannot communicate because they are sort of like humans, right? If we have different world models, it's really hard for us to come to the grounded reality, to establish the grounded truth. And because agents are way more similar to humans than to the apps, at least, again, the newest generation, they're super smart, super creative. Like, because of that, this doesn't work, because it works like in theory, but when they sort of hit each other, when they start communicating with each other, they essentially quickly discover that their world model it's completely incompatible, and they become useless. So because of that, I think that's another sort of argument against the document databases in this particular year in 2026. So yeah, I like, again, I in general, I agree with your argument about like it can go to the reality where everything is sort of mess. I would like, my pushback would be like, it's still kind of, you can enforce the schema on the application level, which sometimes is good, but it doesn't work for agents.
No, but
So
it doesn't scale.
only
That's the thing. What I think is,
yeah, it doesn't.
And that's, I think you're agreeing with me actually, and you're saying the same point. Whereas, like, it's conceptually the same if you have, let's say, 10 agents working on a no schema code base, and then they come up with 10 different schemas, or you have 10 microservices by 10 different people. Eventually, just the coordination layer between these agents or people writing code eventually breaks, and that's when you get the mess.
Well, with microservices is easier because it's sort of the contract. You agree on the contract and you work like for a long time. This is go back to the compression of time, right? If you work on a linear time scale, it's fine because you can rearrange the contract. But if your contract change every 5 minutes, this is what breaks it.
Yeah, I mean, I think the other lens to it is that I think also when we think about what I said earlier around essentially not just building a database, but an abstraction level above, right? If you think about sort of database in the past, sort of like, you know, maybe APIs or ORMs and then applications on top. So now if we think about the fact that, you know, most agents will be doing the work, we can sort of remove these UIs or applications out of the equation, where a lot of the guardrails and kind of like logic or business logic lived basically, and kind of falling down the stack essentially. And what it means is that essentially database needs kind of now handle more of that logic that previously lived like siloed in applications, you know, and that means obviously the schema enforcement, but also things like policies, and also even the kind of the interface you expose in terms of retrieval that often in the past would live at sort of the API level, right? And it would kind of resolve to the actual underlying database. So in some sense, I think this is kind of the interesting part of like really sort of like what happens when you remove the UI in applications and what you end up with essentially for agents to interact with.
So you said earlier that also you build on an open stack, so sort of like Lego blocks. Can you define it a little bit more, what that means?
Yeah, sure. I mean, I think if you could think about, I guess, the database, right? You have at the lowest level, of course, you have like the storage, right? Like the underlying files, so the file system. And there are obviously these kind of open standards like open table formats like Iceberg, and you know, building on top of Parquet have emerged, and then we're betting here kind of on Lens, and then you have obviously the query engine that kind of resolves the query. You have like the policy enforcement, right? The reason we kind of bet on Lens is that so they built a really interesting kind of format that solves a lot of the issues that Parquet had, for example, around adding new columns or also random access. They also natively sort of support multimodal data like file blobs and things like that. So yeah, we're building on top of Lens and then using sort of DataFusion as the query engine, and then Arrow as the sort of in-memory data formats. I think often when choosing technology, it's like partially a question of, okay, using something that is superior in terms of its properties, but at the same time also focusing on distribution. So how well sort of adopted is that piece of technology, because that determines also what, let's say, customers will work with, but also what will get actual long-term support, right? In some sense, we were kind of doing a mix of the two bets, right? Because if it was purely about distribution, we would have gone with Iceberg specifically, but because we're also balancing with essentially also the completely new changes in workloads and also being sort of having an actual infrastructure advantage for that, and that's really kind of falling into favor of sort of Lens essentially. But Andrew, did I miss anything?
Yeah, I mean, in terms of like overall model of like when someone is building something, they're making a lot of trade-offs, right? And that was also mostly was defined by the technology that, for example, if I know Ruby on Rails, right? If I'm really good Ruby programmer, I would limit myself to this ecosystem, right? There is no way for me to use the tools unless I wrap them, and from, let's say, Python or TypeScript or something like that. So now what is happening, because agents are like unlocking so much of the different sort of ways to think about different technologies and different ways to structure your stack, I think for me the most fruitful thing is just like you look at the technology and you look into this from the first principles. Like, it's not like you were say, okay, if I implemented this, what would be my downside? What would be my constraints? Although you still, of course, need to think it this way. But you think about like, is it good enough? Is it like beautiful enough? Like my experience with Lens, it's just beautiful. Like I go to the, like Lens is the file format essentially and the SDK on top of it. So like you use the same file format to store like different multimodal data. And it was, first, it was inspired by the Parquet, which is another way of storing data, which was the binary, just to compress a big data set. But it was like, it was what it was. The Parquet is what it is, right? It's essentially compression of the tabular data, of the rectangular data. But Lens went one step away, or maybe a few steps away. How can we create the file that stores so much data and metadata and have like the random access and not breaking, is actually reliable? And the way they did it, like when I went through the mouth, I was just like completely blown away. I was just like, oh my God, this is so beautiful. It's really like one of the most creative and interesting and human, like there was like human ingenuity embedded into it. And because of that, I was just like, I don't even want to think about like, because like before we started building Omnigraph, I built a NanoGraph, which is kind of the little brother of the Omnigraph, right? It's like tiny embedded database, and now we sort of merging them together into the one offering, or like several sort of modalities for the same database. Because, for example, you can take the Lens file, the set of Lens file, and view them like and run them locally, or you can just use the same ontology and then scale it with the server. But this is what we're working on right now. But like the idea of like looking into the Lens and saying like, oh, you know what? I actually need to go through like Parquet. I actually need to go to the Iceberg and figure out like what is the downside, what is the upside, right? I would just like look into this and it's just like, oh my God, this is the most beautiful math I ever seen in my life. I don't want to use anything else, right? And I think that sort of changed your perspective on things, because you're thinking like an artist. You want to think of like, it should be there, it should exist. And you're building something for the sake of existence, which is always more interesting and always more rewarding. So I think like the enablement of this, it's something that, again, very, very few people still figured out, because you can almost like having the taste and having enough of like understanding of the abstractions and the computer science, because to build with agents, you need to understand computer science very well. Having those two things, like the taste and computer science primer, you are now just able to build like incredible things, just beautiful, just out of the pure, artistic or autistic, whatever take you prefer, or like out of pure curiosity. And for me, this is the most, because of that, it's the most interesting moment of like, I think overall if we call it like computers or, computation or, information technology, whatever you call it, I think now it's the most interesting moment, because we built so much open source ideas, frameworks, and now we just like unlock it. Now we're just like, oh my God, now we have access to it, right? Because before that you need to like, to access something, you need to just study and study and study, and it was just like unbearable. But now you can just, understanding the foundation of computer science, you can just look into it and say, oh, now I can use it. Cool. How about I build this? And this is like amazing. I'm just like, oh, it's like every day is like you're in a Lego store, you know? You just like take things that you like, and you just start playing with those kind of yellow and red blocks, and you just have a lot of dopamine hits for this. Yeah.
Yeah. And I think on top of that also, again, I think one has to view always like every organization having the sort of fixed engineering budget and deciding where to put that engineering budget, where you kind of have highest leverage. And so Lens is kind of commonly known for solving first like the multimodal problem, right, of being able to store like file blobs, images, and videos, and things like that in the file format itself, or like essentially on the same spec. But at the same time, also enabling sort of like billion scale sort of vector search. But I think the underappreciated part that they solved is first this random access problem, right, of that essentially Parquet is really bad at, and at the same time also solving a lot of the kind of lower level database complexities like MVCC, like asset compliance, versioning and branching that we kind of all rely on. And so it enables us to actually build at a high level, as I mentioned, like more focus on the domain model essentially, and really kind of the agent interface rather than solving like a lot of the very low level parts. So in some sense, like this format kind of provided much more than anything else in terms of the database primitives, and so we could actually focus our effort on where we provide like most value.
Yeah, nice. And I just realized we've passed an hour without actually introducing you guys or the company. So can you please define who you guys are, and most importantly, what is the product you're working on exactly? Like, what is this graph thing we've been sort of talking about so far? What does it let people do?
We are Modern Relay, and we build in products around this. So that we call it like coordination substrate, right? Or a context and coordination substrate, where like the layer for agent to coordinate, communicate, build things together. And the main product that we're working on called Omnigraph, which is kind of comes from its own name. It's the graph for everything. So that acts as the sort of like a way and almost like the substrate, probably the right word, for agents to just use it and to dump a bunch of data into it. It's going to be completely structured because it's impossible to make it like unstructured because you have the ontology and the schema. And pretty much a lot of things that we already talk about, right? The schema is code, policy is code. We talk about that, like building this lakehouse format with the lens format, right? Where you have like the storage and compute separately, where you can store the storage, scale the storage and scale the compute separately, which is beautiful because in a traditional database, you need to scale them together. I guess one thing that we haven't touched, it's branches. And this is something we really, really deeply believe in. And I think I will pass it to Ragnar just to maybe you could unpack this a bit.
Yeah, sure. I think in the past kind of discussion we were talking about like guardrails, right? And so one thing, of course, of like guardrails in a negative way, at kind of like sort of almost avoiding sort of issues and mistakes. But I think the more interesting thing is about the upside of guardrails, and that essentially they enable you to actually use AI more than you could, basically, because you know that essentially in that bounded space where using AI, you can sort of max really the use of it. And I think even if we look at a few examples kind of have emerged, like, in the space, for example, Kapati's auto research, I'm sure if you're familiar with it essentially, but it kind of uses, I guess, an agent to come up with new architectures of the nano chat or like transformer, and essentially evaluates at each point sort of the inner loop, essentially the new architecture in terms of validation loss, and kind of accept, rejects, and based on essentially an increase in validation loss. And so it provides like a really sort of tight, guardrail there on how to use the LLM. So the LLM here is really kind of can be almost sort of used to its maximum to come up with just completely wildly new architectures, right, based on like past learnings. Because at the end of the day, if it either doesn't compile or parse, or if it doesn't pass the validation loss, you kind of just reject it. And so similarly, I think we think that the reason also like a lot of the AI is kind of underused in companies is that we don't trust it also to write to a lot of these production systems, or we kind of only trust in a way that we have a human sort of like really supervising the whole process sort of end to end. And so what it means, I guess, in terms of like agents, becoming actors is that they're able to write essentially information that drives actions or decisions. But the problem with that is obviously that we have no kind of concept of governance or essentially separating proposing from committing, right? Because essentially when we think about databases, they were designed for applications where essentially the writer was trusted, right? So either you had kind of the guardrail on the UI side, and then essentially it writes to the database, and then what you submit to the database is immediately trusted and kind of committed. But GitHub solved like a similar problem in that we need a way to kind of propose changes before they essentially get accepted. And we think that this will be the ultimate unlock as well for agents who kind of become actors and contribute information, because it allows us to kind of separate proposing from committing. And that doesn't mean that essentially humans are going to be essentially reviewing every change, right? Because they can essentially also leverage similarly agents to kind of review its own outputs, or other agents to review different lenses of this. And so this branching of data really allows us to get actually maxed out on AI, because essentially worst case a branch gets discarded, but allows you also to kind of gradually increase automation, right? Because you can imagine initially every agent write is sort of proposed and then needs to be reviewed by a human and accepted. But then as you gain confidence in specific workflows, you can start auto-merging those, right? And based on like past execution, things like that. And so you can apply this sort of to different workflows in different ways. And sort of with you kind of view that sort of really at the ultimate unlock. But it kind of also partially also solve some of the coordination issues, because I think coordination issues come when essentially multiple entities try to mutate the same thing at the same time, and the applications of these. But essentially the branches allow essentially longer running tasks essentially to solve concurrency, I guess, by isolation and parallelization, and then essentially resolve the state essentially later down the line when essentially more information is kind of gathered. And so that essentially avoids that, almost like intermediate states of agents kind of collide with each other, right? And so to summarize, I think view kind of branching as a way to really actually leverage AI more than you could before, because you can really trust it to run all kinds of automation in the background. But then at the same time also solving like some of the concurrency issues that are really sort of important for coordination.
Yeah, I would add one thing. It's just like during the history of the computers, we invented so many amazing things and so many like really, really clever solutions, but tiny amount of people use them, right? Like for example, with the terminal, like how many good terminal tools we have, like hundreds. But to use them, I need to be like the completely autistic on this kind of terminal thing, right? I need to learn how to do this command, how to chain them, how to run bash and so on, right? So like I need to be like crazy autistic. And I think like with the branches, it's the same thing, right? Like if you use branches skillfully in Git, you would be unbeatable, right? You would be like the unbeatable developer because you could afford so much more, right? But to do that, you need to, I need to create a branch, and this is where commit comes, right? And this is where like, how do I push it, right? And where it lives, so you need to store so much in your operational memory, and you need to be good at this to make this technology work for you. But technology is there, it was invented by brilliant humans. And now we can utilize it in so many more use cases and scenarios, because the technology by itself is absolutely insanely brilliant, but it's also absolutely insanely complex. If you try to explain the GitHub to someone who is not technical, you will see like they suffer, like literally their brain started to just like squickle. It's horrible, right? But by itself, technology is amazing. So, and now we just unlock it, right? We just say, okay, how about you will get the GitHub, but actually without the overhead of managing the GitHub. And you could get it almost like for free. And this is one of those things that also kind of comes with the, like, this is something that we want to emphasize because it's the primitive that is just, again, very, very few people and very few big players understood it. But I think this is the primitive where that is just vital for the agentic workflows. Like really vital.
And I think the interesting part is also, apart from the governance aspect, what it sort of also allows you to do is essentially parallel solutions, right? Because you might essentially have a specific task, but then essentially you can vary the prompt, right? You can vary sort of the input context and all kind of different things. So that actually allows you to kind of almost simulate like parallel worlds, essentially before you actually decide on the right one. And we're already seeing that, obviously in the use of ChatGPT and similar tools, that often people explore like different prompts, different models, different things, right? Because obviously there's variance in the outputs, and also to be able to even test like essentially more deterministically what are essentially the better solutions, basically, right? So it just kind of unlocks a lot of use cases, especially if the kind of the complexity is handled more by the agents themselves rather than relying on humans to kind of like operate all these sort of different branches and things like that.
Yeah, I think all the context I have to add here as well. First of all, to your point, Ragnar, I love giving my agents a Git rebase to fix. That's one of the happiest things I've learned how to hand off to agents. They just do it so perfectly. And the analogy to Git, I mean, GitHub popularized Git, and I think a lot of developers know Git from a high level in terms of, I think they understand branches and merging and maybe squashing. But I found that, me included, that a lot of engineers actually don't understand Git at a deep level. I think a fair amount of engineers I've worked with don't understand rebases, for example, and have a lot of trouble with them. Or when you have a lot of different concurrent branches and different heads and everything, people get confused in that sort of way, what's based out of what, etc., and the hashes. So I think that's a good point, a valid point, in that, well, as humans, we've learned how to use, the highest levels of Git to be productive enough, but potentially there's more. And I think the model has definitely proven itself to work in terms of branching and merging and reviewing. One thing I love to hear from you guys, or I love hearing from you guys, is this gradual auto merging idea, gradually gaining confidence with how the AI does things, and then like everything is gated by a human, but the more and more you do it, you, I guess, tweak the thing and it gets better, and then you actually let out more. That's an amazing idea. You guys are very AI built, like you seem very cracked in the world of AI. So my next question would be, how do you use AI today? Like how are you building this company Modern Relay? What's your workflow like? I'm sure it's probably very different from the usual engineer's workflow.
I will take this one because this is something that I'm working on right now. So this is the cool story. So we had the Slack channel, Slack workspace that was created by people, for people. So the problem with it was optimized for people, right? So everything sort of built around like how do we communicate and how do we sort of interact with each other and so on. And now what we're doing, like right at this moment, we created the completely separate Slack workspace that is optimized for agents, right? This is where like the Devin communicate with Hermes, communicate with Claude, and they work for us, and we will just give them the comments. Like we will just give them the comments like, oh, this is good, right? We will select the reaction, right? Like, hey, good, and so on. So the way we transition now to the work, and this is like, for example, we use the linear for some time, right? For a developer workspace. Why? Because like we don't need a graph, right? We essentially we built Omnigraph, like two of us. There was like some other contributors, but like most of the contribution done by us, right? So why do you need the graph to communicate between two people? That's a silly question, right? It's probably you don't, right? And that was our understanding. But then at some point we hit the level of complexity that wasn't allow us to manage and model our developer process. Because something is dependent on this. Something is dependent on the upstream library changes. How do we implement this particular gate? How do we implement this particular scenario, right? And it's like the complexity grew and grew and grew. And this is where we hit like literally like the ceiling of the linear, because it became like unhelpful, and the agents start to get dumber. Like they get smarter, and like the more we push into the linear, right? They get smarter and smarter and smarter, because like agents, again, very good at using linear as a task management tool, or beats, the same thing with the bits, right? But what we hit is just like, okay, now when we hit the ceiling, how about we use Omnigraph to build Omnigraph, right? And the beauty of it was we created the ontology that is fully aligned with the way we operate and with the way we work. Like, for example, we have this invariance, like the statements that should be true, always be true about the code, right? And if they not, they are essentially like a gate, like a gateways, right? If they are not true, that means the pull request shouldn't come through, shouldn't be merged. So we implemented the ontology around it. And that unlocked a lot. Like even like I'm working on this right now, and I see like all of these dependencies, like how we tried to model them on linear and how stupid it was. Not trying to offend linear. Linear is a great product, but like just
at the time.
I mean, even for most things, because we're building something super complex. For most teams, I think linear is still pretty good. But like when I sort of re-engineer things to like graph first approach, I really saw how like, oh my god, this is exactly what we need. And that was this moment of like real dog fooding, because we try to dog food like almost like theatrically, because again, we're a small team. Like, do we need like a really developed graph? Do we have all this complexity? Probably not. I mean, we can do a theater where we can create a big graph because we are masters of it, right? But do we really need it? Sometimes yes, sometimes no. But when we hit like a real limit of like our issues and our gateways and our invariants and our principles and our upstream and downstream dependencies, like when we hit like limit for real, it became so evident that we need to use Omnigraph. That was such a cool moment, because okay, now we can use our product to build our product, and it was like the ultimate dog fooding. So now our Slack workspace works like this. We have like a bunch of agents operating Omnigraph, creating the issues, doing pull requests, collaborating with each other, chatting with each other, like doing code review, both in a Slack and in a GitHub. And we're essentially almost like the gods. We essentially look at them and we just like say, okay, this is good. And sometimes we give them like a cue or like, a little tip like, oh, looks like you're not going there with the right direction. So this is like what we're building right now on top of the Omnigraph. And this is one of the most exciting projects I ever built. I'm just like looking at this, and this is like so beautiful, so amazing. Like it's completely different paradigm, because it really, like, yeah, you're right. We completely cracked on AI, but we didn't see it. We literally spent a lot of time just chatting with each other in the Slack and try to, introduce the Hermes there, and Hermes started to sort of take some work, but it didn't work that well. And the big moment for me was like, we were thinking about like how we can hire someone who will be like a chief of staff, right? Like, because we need a person who will be totally operational, totally like on top of everything, because we have a lot of stuff, investor relationship, partnership, design partnership, clients, adopters, community, apart from code as well. So how do we, essentially the question was like, how do we hire this person? How do we structure this person work? And I started to like literally creating a job description. And then the biggest light bulb for me was just like, oh, actually, I think Hermes can do it. Oh, actually, Claude Code can do it. Oh, actually, Devin can do it. And I was just like, why are we not using those guys? And we're trying to hire someone, and we know the agent will be better at this. And that essentially give this like ignition point and inception point to this project of like creating completely correct Slack where the bunch of agents interacting, operating Omnigraph. And this is something that we're working on right now, and we will have the cookbook for this as well, just for everyone to try it right away without any prep, without any sort of design.
Yeah. And I think also that also comes back also to your original question, like why a graph as well. And I think one of the biggest problems with agents is essentially the recall problem, right? Essentially that there's a specific piece of information that it's missing that would actually completely change its behavior, right? And so, for example, that occurs quite a lot in code, like first, especially at the code level, right? Because you might be changing something and then essentially, there's this big dependency that this depends on, or like that would affect it downstream, right? And somewhat we already have a graph at the code level because we have like inputs of files, right? We have the syntax tree, right? And so like agents already operate on a graph, so they're able to kind of traverse what depends on what, right? But this is kind of very difficult to do, I guess, with a language or with information when things essentially, for example, a person is mentioned, but it's all essentially mentioned in different ways as named in unstructured and not linked to each other. So in some sense, like actually indexing by linking things essentially allows the agents, when it looks at that entity, to see, what has all the other things I know about this node basically, and really solve kind of the sort of recall problem, right? And it might mean, for example, that an agent looks at a specific person, right, in the database, and then essentially the recall problem would be like, oh, I didn't know that we already reached out to that person, right, because that's lived in some other markdown file that is not somehow linked, basically, right? And so like essentially that behavior is like super critical, because now it would message that person again without knowing that critical piece of information. So you can think of the graph also as kind of like indexing relationships to optimize for like recall, which is like super critical. And also in the case of like this code graph, this replacement of linear that Andrew mentioned, it kind of partially was also addressing sort of this coordination issue, because when an agent looks at a ticket, might think, hey, that's an easy one, I'm just gonna implement it, but it turns out it had to touch almost every other file essentially to solve that, or there might be some upstream dependency, or there's a bug that needs to be resolved in a different library underlying format. So we have like all these kind of relationships, and so coordination so fundamentally works the best when you have essentially decoupling, right? Because the coordination overhead is the biggest when essentially multiple entities need to work on the exact same thing at the same time, essentially, right? So essentially mapping this out, this dependency, allows you to kind of assess like how much decoupling do you have, so that you can actually work in parallel, and so allows really for this kind of parallelization, and it's fundamentally also how every complex system needs to have somewhat of a version of like decoupling, or sort of like or like bounded complexity, right? Because if in your body, every cell depend on every other cell for something, or need to account for every other thing, essentially it would be impossible, right, to essentially coordinate all these actions across the body, basically. But we need a way to kind of essentially decouple things in order to actually resolve coordination or achieve like more complex things. And so actually Cursor worked on this like problem, right, of building this browser that essentially is like a long horizon agent task, and they tried kind of all kind of different things, because they were fundamentally hitting sort of the coordination problem, where somebody would rewrite the plan right while the others were implementing it and things like that. And that's why we think like over time this is going to be one of the most important problems to solve, is actually how do you allow multiple agents to work together in a productive way. It's easy if like you employ agents in a sequential way only, so one after the other, but obviously that fundamentally limits the throughput. And so those companies who are able to kind of actually coordinate and parallelize essentially are really going to win. And this is fundamentally about understanding how to decouple systems, and then naturally also like a graph allows you to be explicit about these dependencies, and then essentially find out like what are optimal sort of areas to parallelize versus to do sequentially, for example.
Yeah, I think
but yeah, I mean, Git is a solution for parallelizing work, right? For humans, at least in a code base. So branching is that.
Yeah, exactly. Yeah, this I forgot. Yeah, actually, the branching comes in as well, because you might be able to work on areas that have like higher sort of coordination pressure. But if you do some branches, it's fine, right? But if you don't have a concept of branches, now you would have like direct conflicts, right? And there's no way this is going to work without having the concept sort of branching there.
Direct conflicts all the time, right? Because also if you're doing, let's say, 12 changes, you might hit the conflict 12 times. Whereas in a branch, you do the 12 changes and you hit the conflict at merge time, which is just once at the end.
Exactly. And you also have time to essentially let agents reason about essentially the semantics of merging it, right? And the implications of merging it at that time, rather than like,
when it's half done.
Like, yeah, because currently most of the concurrency models around data is like, optimistic concurrency, or, like last write wins and things like that. So, but obviously this doesn't work for this kind of long running, operations that agents perform.
Yeah, I think we like, as this sort of meta narrative for our today's podcast is just like why graphs, and I want to maybe like slightly tweak it in terms of like every technology that is get widely adopted before people kind of doubt about it, right? Like for example, I would imagine every person who used the horse would think like, why car, right? It's just like, what's the point? It's like noisy. It's it produces a lot of nasty smells and so on. Horse is kind of more nice. It's alive. It's beautiful and so on. So now probably there are like very few people would think about the like, oh, why not horse? And I think this is that would be my prediction. I think this is something that will happen with the graph. I think at some point we'll look back into the like stuff that we use, and again, everything will be multimodal and multi-paradigm, right? It's like it doesn't mean the graph paradigm will win, but it will win just by sheer versatility, because graph like table can be represented as a graph, list can be represented as a graph, sequence can be represented as a graph, and so on. So it will win. My prediction will be it will win by shared versatility, by sheer versatility. And we'll look back and we'll think, oh, how did it come up that we didn't use the graph? So I would say in 2 years we can pick up my prediction and see where it lands.
Yeah, I mean, in some sense there's still like a convergence in the market, right? If you look at a lot of the solution people are converging on, let's say also Gary Tan's sort of GBrain, right, essentially implements a graph there.
Yeah.
And we're seeing like also ourselves, like a bunch of people getting interested in graphs, even like non-technical people that sort of converge independently on the solution. So I think there's still, it is becoming less contrarian now as kind of time goes and as people see what the limitations of agents are and what they really need.
Yeah, we talked a little bit about this in London, but it's similar to the knowledge graph idea, the second brain idea, the Obsidians, the Rome researchers. We recently had some people go viral on X talking about, or basically opening people's eyes about how useful the knowledge graph is for agents. And I think anyone who's into these things, into data, eventually sees a graph and has a mind-blown moment of like, oh, wow, this is such a good data structure. It really, like, that's why the knowledge graph got popular, because to your point earlier, the graph is, I think, sort of the most natural way to model real-world data or real-world human relationships to objects and to the real world. So it would be great if we can teach agents to do it.
Mm-hmm. Yeah, I mean, even if you look at what has emerged, the tooling around like the SQL databases, right? We like almost everyone has been kind of using these ORMs like Prisma and Drizzle, and there's like a bunch of others in the past, right? Because there was this, object independence mismatch, right? Where essentially fundamentally in the business we're operating in terms of objects that relate to each other, and then we had to kind of map it to tables and relationship tables and foreign keys and things like that. So in some sense, this has already been, the pattern already. So this is kind of more essentially, this is the most generalizable way to represent the information, essentially.
Yeah, I mean. Yeah, ORMs, when I use an ORM, it's a user.friends, and that's basically a relation that we have. Mm-hmm. That's why it's called relational databases. They form relations, which are our basically graph connections. Mm-hmm. Yeah, I mean, amazing stuff. I think we just covered a lot. Is there anything more
we nailed it, man?
Is there anything more you'd like to add about your company? Are you guys hiring? Are you looking for customers? How you have open source projects? Yeah. I mean, you didn't even say it more than that. Omnigraph is our open source.
Yeah, we are open source, so we want you to go to the Omnigraph repo and try it out. It's free and it will be free forever. We will not, our goal is just to, get as much adoption as possible. And we really enjoyed seeing people using it, and it's beneficial for us as well, but it's also beneficial for them, for users. So yeah, that's kind of total win-win. It's again, it's free, and Cloud Code can set it up for you or any other agent. And also we're hiring, first of all, we're hiring the DevRel person. This is something that we would be happy to chat with the people who really enjoy building dev communities, really enjoy kind of navigating open source ecosystems and so on. And also we're hiring engineers, as always. So if you cracked on AI, if you enjoy building around heavy data, data heavy environments, yeah, we will also keen to see your CV or your commit to Omnigraph as well. Like if you want to work for us, just commit to Omnigraph and we will notice you.
Actually, maybe let me think of one last thing that maybe you can talk about, and this is kind of the problem of essentially long horizon agent systems and also coordination. So if we think about essentially the coordination problem, I think there's three approaches kind of that are sort of being taken at the moment, right? You have the sort of central orchestrator sort of idea, right? That you have this one master agent that sort of assigns tasks to all the sub agents and kind of holds essentially the world in working memory and decides what to do next and things like that. And then obviously there's sort of this kind of message passing approach, of agents passing messages to each other. But the thing that sort of the approach that we are sort of opinionated on, and I think the long run is the only one that will work, is essentially the coordination concept of stigmergy, right? Which essentially was quite an occasion more in the natural world of how essentially ants coordinate via sort of shared pheromone trails, right? Essentially kind of open your thesis that the only kind of reasonable way to coordinate over long horizon multi-agent systems is to coordinate via shared state, right? Because essentially coordination boils down to essentially every agent to share a world model, right? And of course, like message passing relies essentially is almost like if every agent is to communicate with every other agent, sort of like a n squared type of kind of situation in terms of synchronizing information, but also because it's unclear essentially which agent needs what information at what time, right? And so the only way kind of really to kind of bound the complexity of this essentially to having like a shared world model, shared state around which kind of agents are really kind of coordinated, and that means also that events there needs to be kind of a first-class citizen, so that if changes happen to that shared state, it can trigger sort of appropriate agents. And so the former method, like of the orchestrator, it kind of works maybe in combination with this, right? Because if the problem is small enough, right, you can actually have an orchestrator that launch a few sub-agents and then kind of, combines the result and things like that. But any sort of like, sufficiently complex problem can't be held sort of like, in working memory, but sort of needs to be kind of decomposed, right? That's the similar reason that even if we have AGI, we have finite compute and memory. So that means there's no infinite, essentially, ability to kind of reason, or solve a specific problem. And even now we have AGI where we have humans, we still need essentially coordination, right? So in the case of organizations, we have like some level of hierarchy, also shared state as well, like CRMs, documents, ERPs, things like that, right? But then also at the level of the economy, like how is it possible that millions or billions of humans are able to essentially perform a global behavior that's coherent, right? We have economic growth, somehow people are producing things that other people like, and then people are getting fed, right? And essentially because we are all able to coordinate via a shared like price system, right? So if the price kind of like gives the signal if like your good essentially is valuable or not to the economy, right? And so we're able to kind of solve that. And no single actor in the world will be able to centrally plan the economy, right? Because there's just so many things happening in the world to hold sort of a finite, memory and compute essentially. So there will always be a limit essentially to the central orchestrator. And on top of that, also like a lot of the things that you need, to find the right path are discovered along the way, right? So even if you look at when you're coding, it might have an assumption, and then when it actually executes, it hits like essentially like something that invalidates the plan, right? And so like a lot of the information that is only found along the way. And maybe the last lens as well is that in terms of the orchestrator, like for most complex things, like let's say finding a new drug, right, or essentially running a successful hedge funds, it's impossible to know how to get there, even like with sort of infinite intelligence right now. But what we know is like we know sort of locally correct steps, right? So that, for example, if you want to develop a successful hedge fund, right, you need to kind of backtest your hypothesis, or you need to have a workflow where you kind of research literatures for market inefficiencies and come up with a hypothesis and things like that. So we know kind of locally correct steps. We don't know the full essentially like path there, but essentially so then the coordination problem becomes like, how do we actually compose locally correct things we know into essentially a global behavior that works? And so and even like for example in the case of developing a drug, right, we know a lot of the locally correct steps, right? Like what things need to be, we need to validate with experiments, how we come up with individual hypotheses and things like that. So this is the kind of fundamentally how we see also the long horizon sort of multi-agent systems in general, kind of automating really important economically valuable work. And this is exactly sort of the infrastructure that feeds that. So the graph itself acts as this shared coordination state, and everything we build around it, right, from, for example, CDC, like emitting events that agents can react to, branching, all these things, they essentially serve to solve this really sort of long horizon agent problem.
That I love that analogy to markets. You've been alluding to markets a bit. It's taking me back to my economical days. But this idea of it's really like almost like communism versus capitalism, where one of the reasons why communism failed is because when you centralized all of the economy, which is millions of people, into like one person's brain or into one committee's brain, they're just unable to process all that information and make good decisions because they have limited CPU and memory or brain power. And the real secret about capitalism, or maybe more like free markets, is that the information that the local market has travels to across the globe and globally almost organically. By like a simple example, let's say you have a furniture factory in Romania, you're making furniture by wood, and let's say all of Romania's forests catch fire and you don't have any more wood, the price of that furniture goes up a lot. But the furniture factory in China, let's say, still hasn't had its price go up because, I mean, they're producing wood normally. Then when the demand sees the high price in Romania, they eventually move their demand to somewhere else, let's say China. They buy out all the wood there, or the capacity they have, and then the price rises there. So you get this sort of the signal that Romania's forest is on fire and there's no wood there left is not known in China, but it's felt, and it's understood by the fact that, well, our demand is going up, the price is going up of furniture across the globe naturally with this information travels, and there's very little bandwidth to the whole thing. The only thing you're sort of conveying is the price, right? It's just the price that's changing. There's not no more tokens than that.
Exactly, and also that comes also to the point of like bounded intelligence and how much information you need to process. And in order for the economy to work, you don't need to know that, as you said, that for example, fire broke out in Romania to, for example, as a consumer, either switch to a different type of furniture that uses like metal in terms of wood, or that you decide to start a business that produces wood in a cheap way. You can act locally correct in a way that kind of contributes to a good global behavior without essentially having global information, essentially. And I mean, this kind of alludes to the economy because Hayek wrote about this kind of aspect of knowledge. I think it's called the use of knowledge in society, right? And that how also knowledge is like distributed, and sort of argues against sort of the central planning in that sense.
Yeah, amazing stuff.
Yeah, I mean, and anyway, I mean, this is also kind of the problem that Anthropic and the frontier labs are kind of focused on right now, and that ultimately, as the models are good enough to perform locally correct actions, it boils down to now a coordination problem over long horizon and multiple agents. So if anybody from the frontier labs hears this, we have the solution. No, but I mean, like, just more practically, I think like what it looks like is also that essentially with this graph, you can actually test a lot of the hypotheses around how to design essentially a system that coordinates well, because partially this is about which prompt you use that essentially act on that graph, right? One kind of enriches the graph, the other one performs like another workflow, but the other one is also how you design the ontology that, for example, you have more decoupling, that different agents can work on different parts of the graph without colliding with each other, and then once the results are kind of done, it kind of propagates to the right place. So you can actually imagine if you were able to essentially launch 1 million graphs with different configurations, and the configuration is the ontology, the prompt, and things like that, and then kind of see how they evolve over multiple hours and days, and basically then you can actually almost kind of learn essentially what are the right sort of coordination primitives versus not, and you can have cheaply explore also with branches without sort of copying every sort of piece of data again. So I think if the budget is there, you could actually use this infrastructure really to try to solve like these coordination problems.
Yeah, that's a great point about the explorability. One good point I've heard about AI is that it's really taken the cost of exploring different, let's say in the context of code designs or different design approaches, to zero, right? You just run 10 agents, have them explore to the logical end, and then you can compare the results. Whereas back in the day, you would need 10 humans to do it. It's really not worth the effort. So branching again helps with that. I guess everything comes down to branching, and it took us a while in the podcast to get to branching.
Yeah, it's like sure. you can totally slope your branch, and then like some branches are going to be complete slope, and then if you have like a good mechanism of validation and verification, some of the branches will be not slope, and this is kind of the new, more evolutionary aligned approach. We're not here. We're not there yet, but we get in there.
I mean, the ideal case also when you have also like a good metric to evaluate the branch, right? Because similar to like Karpati's example, right? For example, if you're optimizing for the validation loss, it's very cheap to evaluate the branch whether you should accept it or not, right? You branch with 1 million, and if the validation loss improves, then you accept it. So the question becomes, okay, with information, we don't necessarily have like these kind of metrics, right? Maybe you could do it around like, the Sharpe ratio when you're building like sort of quant strategy or things like that. But I think eventually we're going to have to kind of come up with also ways to evaluate essentially how good a given branch is or not. But I think, yeah, in the existence of like metrics, it makes it like super interesting because you can sort of use the LLM in a widely explorative way, like always tune the temperature, right? And then have like a hard gate that sort of like rejects or accepts only if it's like really substantially improves things. And actually this auto research aspect has been applied to many different things, people like optimizing any kind of things, like many different things that have sort of like, some kind of well-defined metric. But yeah, I think this is kind of combines, like if you combine all these ideas together, I think this is where we're going to get like really interesting sort of outcome.
What's the outcome again? So basically branching over and over, and until you hit like, let's say, a center metric that a human has defined, you accept that branch over others?
Yeah, I mean, it's about like, for example, the reason why, let's say, Karpati works, or even there's this system like Ralph Wiggum, I don't know if you've heard of it, but it's also a way to run like a coding agent overnight. And it's able to work because essentially it has a lot of guardrails, right? It says like you only edit these things, and only if it passes tests, then you can accept, and it relies essentially on Git in terms of the versioning and rollback. And it's still like sequential in that you kind of do one loop at a time. And also in Karpati, it's used to essentially come up with new model architectures. But essentially the branching would allow you to kind of parallelize your experiments and run like many at the same time. But fundamentally, it's like about combining sort of like the guardrails and using LLM as an exploratory sort of system, and then having like a gate that sort of decides whether to accept or reject. And this way kind of like really coming up with kind of really novel ideas, essentially.
Yeah, great points. It's really exciting times we live in.
Yeah.
Well, I think we can call it here. Andrew Ragnor, thank you so much for coming on the podcast. This was super informative to me and interesting.
No, likewise. It was super fun.
Check out Omnigraph. GitHub.com. Modern Relay Omnigraph.